sections 8.3 and 8.4. So we're looking at the constant of proportionality today and equations. So our learning goal is to identify the constant of proportionality of different representations of proportions. So it sounds super wordy, but we're really just looking at that constant multiple in various ways. So that's what we're looking at today. So let's look at this warm-up example. The car paint company provides a perplexing pay graph for new managers. What does the graph show? Which point, A, B, or C, might be the most useful, and explain. So as we look at these different points, I see that after you've worked 1 hour, you've earned $10. After 5 hours, you've earned $50, and after 8 hours, you've earned $80. So we want to know which point, A, B, or C, might be the most useful for helping us understand the pay for managers. So obviously we have one point that is unique in that it tells us the unit rate. It tells us the pay per 1 hour. So in 1 hour, you're going to earn $10. That is the most useful because we can then take this rate, this unit rate, and make any constant multiple I want. So I could easily calculate point B, 5 hours working would equal $50, or point C, 8 hours working would equal $80 if I know point A. So that's kind of what we're looking at today. When we see this unit rate, that gives us our constant of proportionality. We're going to earn $10 every hour. So let's check out some more examples. Our key concept for today is reviewing that two quantities x and y have a proportional relationship if y is always a constant multiple of x. So this constant multiple we looked at yesterday, this y to x ratio, that is the constant of proportionality. So you already know about the constant of proportionality without knowing its name. So if x and y have different units, like they did on the previous graph, dollars per hour, then that constant of proportionality can be written as a unit rate, like we saw in that previous example. Let's look at an example from a table rather than a graph. So let's say that we are looking at the number of bricks used in a wall compared to the total length. So we know that 1 brick is 20 centimeters, so 2 bricks is 40, 3 bricks is 60 centimeters, 4 bricks is 80 centimeters, and 5 bricks is 100 centimeters. This is like my X, Y table. So if I want to write it as a ratio and find my constant of proportionality, I'm going to look at my X or my Y to X ratio. So I put Y over X, 20 to 1, which simplifies to 20. 40 to 2 also simplifies to 20. 60 to 3 reduces to 20. 80 to 4 reduces to 20, as well as 100 to 5. So my constant of proportionality is 20 centimeters per brick. So here is a problem for us to solve regarding the constant of proportionality. If the weight of this stack of books depends on the number of books in the stack, then I know two variables. I'm going to look at the weight compared to the number of books. Now the weight depends on the number. So the weight is my dependent variable, which is my y, and the number of books is my independent variable, that's my x. So if I need to find the constant of proportionality, that's going to be my y to x ratio. So we can then use the constant of proportionality to find the weight of 11 books. So let's look at the two things I know. I know the weight. The stack of books weighs 15.75 pounds. I also know the number of books by counting them. I see 1, 2, 3, 4, 5, 6, 7, 8, 9 books in this stack. So I'm going to do my dependent variable, which is the weight of the books, over my independent variable, which is the number of books. And this is going to help me find my constant of proportionality. So I'm just going to reduce this. So I'm going to do 15 and 75 hundredths divided by 9, and I get 1.75 pounds for one book. So if one book weighs 1.75 pounds, I can use that, my constant of proportionality, to find the weight of 11 books. So let's set up a proportion here. So if it's 1 and 75 hundredths pounds per one book, we want to know how many pounds per 11 books. Then I'm going to ask myself, how do I turn 1 into 11? I multiply it by 11, of course. Whatever I do on the bottom, I have to do on the top, because remember, I have a constant multiple in a proportional relationship. So I'm going to do 1.75 times 11, and I get 19 and 25 hundredths pounds. And that is the weight of 11 books. So I can use that constant of proportionality to find other answers. And we kind of used that concept a little bit last topic as well. Taking a rate, reducing it to a unit rate, and then using that unit rate to find another equivalent value. So let's look at another problem. Each shoebox is the same height. The height of the display depends on the number of shoeboxes. So when I hear depends on, that lets me know my dependent versus my independent variable. If it's my dependent variable, that's my y. So the height is going to be my y, and the number of shoeboxes is going to be my x. So if I'm looking for the constant of proportionality in this situation, I'm looking for my y to x ratio. My y is my height. My height is 45 inches, and the number of shoe boxes in my stack is 5. So 45 divided by 5, of course, is 9. So there are 9 inches per shoebox. Let's say that we have a recipe that calls for 2 cups of flour to make 3 dozen cookies. Your friend has a cookie recipe that calls for 3 cups of flour to make 60 cookies. Are the constants of proportionality the same for the 2 recipes? Are the recipes for the same cookie? How do you know? So let's tackle our first question first. Are the constant of proportionality the same? So I need to identify my dependent and independent variable, or my y and my x, because I'm looking for that y to x ratio. So the number of cups of flour that I use determines how many dozen cookies I make, right? So let's think about how many 3 dozen is. So when I see 3 dozen, I know there's 12 to a dozen, so 3 12s would be 36 cookies. So for every 2 cups of flour, I'm going to make 36 cookies. So let's look to see if these constants of proportionality are the same. All right, so for our recipe, we can make 36 cookies per 2 cups of flour. Okay, so this would reduce to 18 cookies per cup of flour. Our friend's recipe takes 60 cookies, but it takes 3 cups of flour. So this would reduce to 20 cookies per cup of flour. So are the constants of proportionality the same? 18 is not the same as 20, so we can say no to question number 1. Are the recipes for the same cookie? No, those would be different cookies because they are different proportions. And I know because 18 cookies per 1 cup of flour is not the same as 20 cookies per cup of flour, so different recipes. All right, you can pause the video and try this one on your own. So on Monday, we ran 2.25 miles in 22.5 minutes. So that becomes a unit rate of 1/10 of a mile per minute. On Tuesday, we ran 2 3/5 miles in 25 minutes. That's a unit rate of 94 thousandths miles per minute. So are the constants of proportionality the same? No. And I know that because I have reduced my rate to a unit rate so that I could compare them. And they are not the same number. All right, on example 3, we're looking at money raised for a concert. We want to know, does the table show a constant of proportionality? So remember, to do this, we're going to be looking at the y to x ratio. So I'm looking at 3,600 divided by 160, which is 22.5. In my next row, I have 11,250 divided by 500. Well, right off the bat, I am seeing that I'm getting the same constant. So let's check the third row in my table. 16,875 divided by 750. And again, as we divide that, it's 22.5. And finally, we have 36,000 divided by 1,600. And we again get a constant of proportionality of 22.5. So this is my constant of proportionality, and it's consistent throughout my table. So that is my y to x ratio, which means dollars per ticket sold. So it's $22.50 per ticket. And we can sell no more than 2,500 tickets for the concert. Find the maximum amount of money the fundraiser can make. So each ticket, oh my goodness, what is happening here? Oops, what is it doing to my equation? Oh my goodness, what is happening? Sorry, Smart Notebook is going crazy here. Let's just drag that out of here and try the pen again. I'm going to have to erase. Let's try this again. So if it's $22.50 per ticket, then I can multiply that by X, and the maximum, or I can sell no more than 2,500 tickets. So I'm going to go ahead and